This is the Air Force U-2, a versatile tool of upper altitude research. In June of 1960, this unusual aircraft completed a 3-year program aimed at measuring amounts of radioactive fallout in the upper atmosphere generated by nuclear testing. Paper filters in the U-2's nose cone trap particles for later analysis. A small port in the nose cone admits the airflow to the filters. The U-2 flights in the high-altitude sampling program were flown from bases in North Dakota, New York, Texas, Puerto Rico, and Argentina, which covered the Western Hemisphere from the Arctic to the Antarctic. The U-2, configured like a glider, can cruise at altitudes up to 70,000 feet for 7 hours and cover 3,000 miles during this period. Note that on the takeoff roll, the outrigged gear drop off as the plane picks up speed. During the 3-year program, over 4,000 samples were evaluated and the findings placed in the United Nations Library. Information which the Defense Atomic Support Agency has determined will help the peoples of the world understand the unseen and needlessly feared phenomenon emitted by nuclear testing. Air Force U-2, an aircraft with unusual performance characteristics and a unique design, has contributed greatly to this nation's efforts to study and evaluate the presence of radioactive debris in the Earth's atmosphere, a highlight of 1960 research activities. Missile research and development quickened in pace during 1960. On May 20th, an operational Type Atlas flew 9,000 miles downrange on target from Cape Canaveral. It was the longest ICBM flight to that date. The Titan, in late stages of development, made its first full ICBM range flight on February 2nd and gave promise of a new operational ballistic missile during 1961 as the Air Force Missile Test Center began its second decade of missile testing. A new ICBM came on the Air Force scene in 1960. The Minuteman, a solid propellant-powered weapon system, is to be launched from unattended underground hard sites. Early launch tests at Edwards Air Force Base proved highly successful. Since these tests were to study only launch characteristics, cables were attached to the missile to restrain it from flying too far. Hill Air Force Base in Utah played an important role in Minuteman development. Because of its solid propellant engines, the Minuteman lends itself to a mobile launch pad concept of operation. This train is actually a test unit, which may someday deploy the Minuteman around the country on existing rail lines. Because the Minuteman train can roll in random patterns around the nation, it would be impossible for an enemy to pinpoint its launch site for destruction, and complete communications make the system able to respond immediately. As the men travel, they have all the conveniences of home. A crew of 48 Air Force and civilian technicians made several two-week trips aboard the train in 1960 to check out its systems and to determine what technical adjustments must be made before the train is ready to roll with operational missiles. Will track vibrations as the train moves at high speeds produce problems in the missile's delicate electronic and guidance systems. Special instruments will tell. Will the train's extensive communication systems experience problems in maintaining constant contact with SAC headquarters as it flies the mountain railroad routes? Minute-by-minute contact with the command post at SAC headquarters was always maintained, and the system performed so satisfactorily that future plans for deploying the Minuteman aboard these mobile launch pads will add to this nation's deterrent posture. So with the train concept and an underground silo launch capability, the Air Force is developing a 1-2 punch with the Minuteman ICBM.